And then we're going to finally say which side of the reaction is favored. So if we look at the first one, if we write a Kc expression, remember that K is concentration of products over concentration of reactants, each one raised to its stoichiometric coefficient. So K is going to equal, well, NH3 is our product, so NH3, and since it has a coefficient of 2, we're going to square it, over the concentration of N2. It has an understood 1, so we can either write a 1 in here or we can leave it blank and it's understood, times the concentration of H2 to the third power. So here's our expression we would use to solve for Kc. Now if we want to calculate it, we can see that I didn't make this very easy because we have moles and we have liters. So the first thing we're going to have to do is calculate all of these. Now, since this phrase is here, at equilibrium, all we have to do, we know that this is how much we have at equilibrium in a 5-liter container. We can plug those molarities, once calculated, right into here and calculate Kc. Now, one thing that I did not tell you is K does not have any units. Unlike kinetics, the units cancel each other out when you put the forward reaction over top of the reverse reaction, so K is unitless. So let's calculate the concentration for N2. We had 3.01 moles over 5.00 liters, which gives us 0.602 molar. We're going to do the same thing for H2 and NH3. If you'd like to pause the video, calculate them, and check them, now would be the time to do that. So there's our first one. Let's look at the other two. So 0.420 molar for H2, and then for NH3, here's our equation, and we get 0.113 molar. So all I have to do is put these values in for my K expression. So I have 0.113 squared over 0.602 to the first times 0.420 to the third. So go ahead and calculate this. You can pause the video, calculate this, and see if you get the same answer as me. All right, so when you put this in your calculator, these are all to 3 significant figures, so I'm going to make my K value to 3 significant figures, and I got 0.286 as my answer. Again, no units. Since this value is less than 1, which side is it going to favor, the reactants or the products? Well, if you go back into your notes, you'll see that this favors the left. So it favors the reactant side. All right, we have one more problem to look at. That's on the next page. Here is another equilibrium. H2 plus I2 yields 2HI. And this time we're given a Kc value. And we're told at equilibrium our H2 and I2 concentrations are both 0.0250 molar. So we want to find what is the concentration of HI at equilibrium. So the best thing to do is first write an expression. Kc is going to equal products over reactants, each one raised to its stoichiometric coefficient. So HI is our product. It will be squared over H2 to the first times I2 to the first. So now all we have to do is plug in all of our values. HI is going to be our unknown, but we're given Kc, so 1.84 times 10 to the minus second is equal to the concentration of HI squared over 0.0250 times 0.0250. There's an easy way to solve this, and there's an easier way to solve. Well, there's an easy way and a hard way. So let's look at this. This is a squared factor up here. This is squared down here. We could take the square root of both sides of this and get rid of this squared factor. So let's do that. We'll get the same answer if you do it the other way too, which is multiply both of these out, multiply by that, and take the square root of this, or your product. but this is a little bit easier. So I'm going to stick with the significant figures. So 0.136 is going to equal the concentration of HI. Since I took the square root of HI squared, that's just HI over 0.0250. Down here in the bottom, this is the same as 0.0250 quantity squared. So if I take the square root of that, I can just cancel one of those out. And now just multiply these two together, and I get HI's concentration to equal 0.00339 molar. Make sure if you're dealing with concentrations that you have the unit of molar on the end. Go ahead and look at the Schoology site to get the problems that you need to complete based on this. Thank you.